Good evening and welcome you all into this first webinar series called Vichar. It's an initiative by FIAV. My name is Sury Soni. I'm former president of FIAV and current trustee of FIAV and AICCT. This is the series we are going to bring in a guest speaker every week at the same time using the same link. I request you all to promote, share this link and this initiative to wider community and be an audience. Bring your curiosity, bring your questions to our guest speaker every week, and we'll record these sessions for the betterment of the community. We've been joined by so many community members, so I welcome you all. And before we formally start, I'll request Neeraj Nanda ji to welcome our guest speaker. Thank you. Over to you.
Hello everyone, I am Neeraj Nanda, editor of South Asia Times. Today evening, Mr. Soni will talk to Dr. Santosh Kumar, who is professor at the RMIT University, on a very unusual subject, but I'm using the word unusual and I found it to be very interesting subject. Philosophy meets mathematics. Obviously, we will know when he starts what actually he wants to tell us. Dr. Santosh Kumar has also been very active in the Federation of Indian Associations of Victoria and in many senior organizations, as most of you know about it. And he has also been acting in many other community organizations and other academic circles across Australia, including Melbourne and Victoria. Whenever I go, I come across him and we have some intellectual talk. I suspect, it's my feeling, that he is a perfect and pure blend of intellectualism and community commitment, one who stands with the people, who stands with the community. Please welcome Mr. Soni and Dr. Santosh Kumar.
Thank you. Thank you, Neeraj. Over to Dr. Santosh, and if you can start, and at some point when you can share the screen. Thank you.
Okay. Why it is not sharing the screen?
Try again. I can stop sharing and share again. So, general housekeeping rules. While Dr. Santosh is sharing the screen, I'll request all audience to stay on mute. Unless you have some question, you can type it in chat message, or you can choose raise your hand option where I can curate to bring you to unmute and ask the question. We'll have some question and answer session towards the end. And so I'll request all to stay on mute during the program. But I would at the same time request all to turn on your video so we feel we are sitting in a room and discussing this virtual interactive webinar.
Yeah.
Yep, screen is there. Over to you, Dr. Santosh.
Okay. Thank you for giving me an opportunity to talk about this subject, which a lot of people think is a dry subject. And I thought, because of the uh, background of listeners, I bring mathematics without bringing mathematics, you see. So I will here and there touch, but mostly it will be, I want to talk about today at least one ideology which I picked it up and how useful I found in mathematics. And that is what I want to talk about today. I will not go into the details of any problem, but I will here and there inform you that what and how it is helping. Okay. So with that, let me also give you a little bit about my background, that how I came in contact with this subject. So I completed master degree in mathematics and joined defense R&D. I was introduced to operation research in 1962, and our group officer gave us one lecture, and three of us were in the group, and he said, from here, take it on. See, there were no books, there were no courses in India, and we just looked at two journals were published at that time. One was from USA, another from UK, and that was the only source of information for three of us in the group. We all three ended up doing PhD from different universities in OR. I completed from Delhi University in 1968. Got support from a scientist in USA because I just communicated with him. Those days there was nothing electronic. So he used to send me the print material. And in the absence of any other information, I used to read what he was sending to me. So I used to get a lot of copies in the mail. Joined RMIT in 70, taught mathematics to MBA students, mathematics students, engineering students uh, uh, in various 8 universities around the world. I've received 3 times awards from Governor House, and my civil award was in 1921. I've done 5 books and 220 research papers, and I enjoy research and continue to do community work. This is in short about me. Now, what I want to say. I want to discuss ideology and implications. We see implications of everything in the life, as well as some of them come in mathematics also. So, for example, if I show you this particular jigsaw, if the problem was to put this piece of jigsaw in this particular place, it was a difficult problem. But if we arrange all pieces, then it becomes an easy problem. The philosophy is that sometimes we have to do something what we have not been asked to do in order to do what we want to do. See? So this was not a part of the game, but the problem becomes easy provided we arrange all the jigsaw pieces, and then the final problem piece goes easily in the right place. And outcomes are also, it is a function of how you react, what you get, and sometimes you get. So I will be talking about this ideology and outcome in terms of some important meetings I had in my life, and I want to talk about them. So these are the two main things I want to cover. Let me start with a story. This is a well-known story of an old man called his 4 sons and asked them to stay united, and nobody will be able to touch you. This is such a simple ideology, yet it is so difficult. Everywhere there is a disagreement, there is a animosity, and there is and that leads to the weakness, and that is enjoyed by the enemy. It's a story, everybody has heard about it. that he gave one piece of timber to everybody, they broke easily. Then he put the four pieces together and said, break. Nobody could break. So mathematics is something similar to that. Reverse ideology works in mathematics also. If problem is complex, we don't try to attain that complex problem. We look for the cheaper side of that particular problem and get into it. And this is where I see an ideology is working in mathematics. And I found that there were a lot of things we could do with this particular thing in our mind. For example, don't worry about the mathematical notation, but if there is a problem of dividing something into, say, 10 parts, 20 parts, whatever and value we want to have, and sum total is equal and the product is maximum. This problem I came across about 60 years back, that it becomes a difficult problem. But if I look at it in a different way, that I have not been asked that question, but I'm now, for my convenience, trying to look at it that way. That if I divide it in two parts make it further simple because I have to find only one because other part is c minus x. So that follows easily and the problem can be solved. And once we know about two, then we go for the third, and two we know, and that is known as policy iteration, all those sort of name in mathematics. But the idea is that that we solve more problems of less difficulty. That is the ideology. That. And what makes difficult about the problem, we skillfully try and move around in such a way and that we lead ourselves to the place what we wanted to do, and that is also called pathway approach. This will be more clearer in the next slide. Suppose I want to talk about drawing a circle within the triangle. It is slightly difficult, but two is easier. I can touch because taking a good old days compass in the middle line, put it, and I draw a circle. I can easily touch the two lines and then start moving, and that is where the path is coming. You see. So the point is that we try and simplify what we can do in the hope we are able to do what we want to do. So that is the philosophy we are working. Now, here, these problems were discussed. They are not new problems. These problems have existed. But as early as in 2007, we put forward an idea, and that made the problem very easy. What we did, that if I have something like 4 units joining 1 to 2, if I subtract this and add it, so I have not changed the distance, overall distance between them. My problem was to find the distance in 1 and n. Its distance remains the same. But the beauty of 0 is that it's a natural minimum. So what I will do, instead of solving one problem here, I will be finding out shortest distance between 1 and k. K is all these things. Eventually, I will reach the end also. Once again, the same idea. 1 of n is changed to n of 1. So I'm solving one thing at a time. And I'm also, so this concept was not there before 2007. Now I go that what is the advantage? What is the big thing achieved by this? proof of minimum is not required. In mathematics, in many problems, we may have achieved what we wanted to achieve, but there is no alarm coming that you have reached to your desired destination. So unless, like navigation says, you have reached your destination is on your left, you see, so that sort of alarm is needed. And once it is zero, it's a natural minimum. So there is no alarm needed. Every time we are going one step forward, so we know it is a linear relationship. In n minus 1 steps, we will be reaching to our destination. So mathematical approaches are utilizing ideologies, and similarly, we may be able to develop some ideologies based on mathematical strategies. Because both are looking for truth. Mathematics is also trying to find out what exists, and ideologies are based on great deal of experiences and which is also uh, 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 truth-based. Now, taking this concept little bit further, we thought we'd deal with the probabilities. In probability, there is no subtraction addition. So we started multiplying because that is a legal operation in probability. And again, we could do similar thing with the probabilistic network. And perfection, there was 0. Here the perfection is 1. So we could immediately move forward. Not only that, we further investigated that in, in networks, there are directions and there are non-directed networks. Non-directed networks are considered difficult because that piece of information about the direction is missing. So this very idea was tackled in a very difficult way some time back. But when we dealt with this particular concept of breaking the problem, one problem into n parts, we have been able to get the solution to this problem by the same idea. Concept 3 was that we were able to get the convergence even faster than the directed network. And that work was published 2011. I think it is 2011, 2012 or something like that, around that time. So that it is that recent. Based on all these simple ideas of 1 of n to n of 1, that is, solve several problems, simpler problems, with the intention of reaching what you want to do. This all material is coming in my book, which might be published in a day, 2. I don't know when it is likely to come. Proof has been read. You see, it is just coming. So we call it reconstruction because we are changing. Sometimes we are changing the network, sometimes we are changing the link weight, sometimes we are changing. But the concept is that we are dealing n times, dealing with one thing at a time rather than one problem of n dimension. So this work is under, there are many more things in this book, but here is a simple illustration, example of that. Now, how mathematics can be useful? I tell you two simple things. When we used to pay bills, there was no online payment by postal, by check. I did my simple arithmetic by one of the formula we teach in the classes. And I found that instead of paying monthly, bi-monthly was better for me. I was saving some money. Not a significant money, but I was saving some dollars and cents. So in normal day-to-day activities, this formula can be applicable. And on the serious side, if you look at, I was reading on the collar of the book, they have saved more than $1 billion for big companies like American hospitals, airline, and Telstra. So one consultant told me, I will be coming back again on him, that he makes sometimes 1% charge of the saving. And even then his bill is very high because the amount of money he's able to save to the organization is large. So these things do matter and do bring money back to the organization. Now, I was mentioning earlier also that I had some very useful meetings in my life, and I want to just touch briefly about them. These people are not ordinary people, you see. They were distinguished people. Let me talk about the first one. Richard Bellman had a short life, 2384. He was not even 65, but he did wonders. He did invented a field in mathematics. He took mathematics to medicine. He started new field. And this caliber person was the person who was sending me books and material when I was in India. So I was fortunate to see him, and I went before his death. I saw him face to face also. And I met him in 74 at his university. So he was working at that time, Rand Corporation. He is one of the big mathematician, and God didn't give him long life, but I will mention about him again. Similarly, this person, George Danzig, I had face-to-face discussion with him. He is the inventor of one field in operation search, and that's called linear programming. His method is known as simplex. Simplex method is one of the 10 significant algorithms of the last century. In the last century, the computers were occupied when we had only mainframe computers. 60% of the time, they were solving his algorithm. It was such a applicable. He is the only person who has been called by White House to honor him. And I was fortunate to have 1 hour sitting face to face with him when he came to Melbourne. Okay. So I just wanted to mention. Now, this person, he also came to Melbourne. Again, I had some responsibilities to look after him, and in that connection, I saw him. Gene Woolsey was not a researcher, but he was a very, very successful consultant. And he made good money, and he was a writer of one of the columns. His column was known at that time when he was alive, Fifth Column. And I was a regular reader of that fifth column. So I went to see him. I praised his fifth column because I was a regular reader. He in turn asked me what I was doing. So that gave me a good opportunity. And I told him what I was doing. And I also told him that what I was doing, I'm in crisis in terms of I'm not getting a identity for my work. So he said, it's a good thing to do, but I don't have an answer. But I'm here for 3 days. Before I go, I meet again, and I will try and suggest something sensible name for what you are doing. So he suggested me protein systems. What it means is, protus is the Greek word, and it means God of sea. Because I was dealing with systems which are not steady. So he says, your systems are protein because sea is never steady. Even if it is glassy, there is some waves all the time going on. I believe all life systems are protein because no matter how good you are a CEO, no matter how good you are in terms of your job, but there is an external, internal element to every system in the world. The more I think the world is protein. There is nothing which works in isolation. And what it means is that you might control what you want to do, but external disturbance is always possible. And therefore, your system can subject to change. So this has given birth to many new things, and I will cover them. Birth of a new type of uncertainty. So statistical uncertainty, distribution, probability, discrete probability, continuous probability, we all know. But here is something which is not following a probabilistic law. It is an unexpected disturbance coming from outside. And it has given rise to another concept, recycling concept from waste management to mathematics. I'll talk about it more. So, most of us are familiar with deterministic and stochastic system. Now, we have got three systems, deterministic, stochastic, and protein system. Deterministic, you know, where the things are being precisely measured. Stochastic, where the things cannot be precisely measured and their outcome is probabilistic. Some outcome is probabilistic, but still you know it. Like when you toss a coin, there is two possibilities of the outcome, head or tail, similarly dice. But in the case of uh, other uncertainties, we talk about the distributions, and there's a large literature on statistical distribution. Protein system has not been studied much. And why the things become protein? Because suppose you are expecting an supply and your supply is stuck in the truck outside because of a road accident. Now your influence, whether you are prime minister or you are CEO, nothing works. If the road is closed, it is closed. So something can happen because everything in every system is not under our control. So we talked about how and why it turns out to be protein because we are not in the in a controlling situation of this. And this has recycling concept. I've applied in mathematics, but it is unexplored. It remains to be explored more and more system. Why we call it recycling concept? Because the system undergoes a little change, and therefore to the new problem, solution to from the old problem may be still possible, and we also call it pathway approach. The above ideas have led to the new field not yet explored. They need to be explored further, completely remain unexplored field. So what I want to talk about. So I was thinking that if the system is protein, in two things, usually you are in the car or you are in a university environment, in a class. If you are in a car, I used to keep in those days when there was disc, some audio books. So whenever I was stuck in a traffic like that, I used to read my book. So I was utilizing my time. And this aspect needs real consideration at a larger scale on other systems. In the university, we have got always, we say that we have not taught ethics, we have not taught. There can be 30 minutes, 40 minutes sessions like we have in the television, one particular uh, 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 display of a certain story, one part. If university employs two or three people and on short notice they go into the class, they talk something which is finished, done with in 30 minutes. So instead of wasting time, it can be utilized. So this is just my thought. But in larger scale, it needs thinking, it needs how to utilize. This is like the job of a MC. When something goes wrong, his responsibility is to keep people occupied. The same thing happens in industry, not only on the show. So what next? I was just looking at it, and here is a quote that mathematics is the only scientist who can lay down on a couch and say he's working because he's still thinking and doing something where to other people he's not doing anything. And I also want to bring to your attention there are 7 millennium problems, and he's saying somewhere here that if we reach to the mountain of these are like 7 mountains. If we can reach on the top of these mountains, we don't know what our vision would be. So they want to see that how these problems and will they ever be solved, and if they are solved, what will be the outcome of them. So mathematics can be that hard. I looked at Newton, and he said that I don't know how I appear to the world, but to me, I was playing on the seashore. And I was changing the pebbles from one is looking good. And, and he said, whatever bigger things I have done, maybe some giant shoulder. He got some giant shoulder and he was able to look. It's the same idea that there are mountains. And if we can climb those, perhaps our vision might change. So this is what he thinks about it. In nutshell, I thought I say the circle of known is always smaller of circle of unknown. We always have more unknown things and they both grow. Circle of known grows every day, but circle of unknown also grows and faster. It goes faster than unknown. And finally, I want to say that research is like an airport where ideas come like passengers. Some are coming, some are going, and they both increase in volume. So,
Very inspiring presentation, Dr. Santosh.
uh,
So kind of you.
one more slide was there. Somehow it has disappeared. I simply wanted to say that if among the audience, if you are in mathematics, I hope I have not misrepresented you. And if you are not from the main field of mathematics, I hope I have given you some light, some interest in this field. Thank you very much for listening.
Thank you so much, Dr. Santosh. And I'll request audience to raise your hand if you have any questions to be asked.
Now, how
Santosh,
do
if you
I
can
stop
yeah,
sharing?
yeah, you can stop sharing unless somebody asks question from one of the slide.
Mm.
And Ravi Sharma has raised the hand. Ravi, over to you.
Thank you, Surya Bhaiya. Santosh ji, what a wonderful presentation. I am a big fan of mathematics and physics, and I haven't pondered over mathematics the way you have. So, first of all, thank you for your amazing work that you've been doing all your life. There's one particular concept that has intrigued me much more than others about non-directed networks. I can't stop to sort of look at applications, and I believe our brain and our neural networks are all non-directed,
yes.
and I think our neural connections are formed based upon finding an optimum path, and then they learn, and that's how they reach. So my question was, how much do you think the nature, probably works on some of these concepts by default, and maybe that's has been a basis of evolution and creation of universe, like I want to understand your perspective of
Well,
mathematics.
what I was able to do, that when we looked at non-directed cannot be converted into directed by putting two links in opposite direction, because
Yeah.
it becomes very cumbersome. And so this concept of adding and subtracting was very powerful, and I wanted to take it to the non-directed network. But when I wanted to take it to non-directed network, first immediate idea was that put two costs in the same link. One side you subtract, another side you add, and but that was not. So I looked at in various ways and came up with a virtual directions concept.
Mm-hmm.
And virtual directions means that when I'm going home, from my home to my work, for example, my road is a two-way road. But for me, it is a one-way road, because I am now pushing myself in the direction of my work.
Yeah.
So I temporarily assigned them direction, and I call them virtual directions.
Mm.
And I was able to take the same concept which I applied for the non-directed network to directed network, to apply the concept of non-directed network to non-directed worker, and it turned out to be that the convergence was faster.
Mm.
Then we looked back the directed network, and we modified them also, because although the directed network was more information was there, all the time impression was that we need less work to solve them because we have got an extra piece of information. But we have now same methodology is working both for directed as well as for non-directed, and that was a good achievement.
And avoiding redundancy in both scenarios.
Yeah.
Excellent. Cool. And I'm a big fan of economic order quantity. I do apply that formula in a lot of decisions that I make in my day-to-day life. And nice to see your example on you paying the bill back in those days using that formula.
Yeah. And the whole idea was that Australia Post increased the postage. At one stage when we were sending the bill by post, I think it reached about $1.10 or something like that.
Yep.
or and the inflation increased the price of the envelope by 100 pack was sold for $4, so one pack was 4 cents.
Yeah.
And in comparison to what the interest I was getting from the bank was
Yeah.
less, so I started paying too much.
Excellent. I love it. All right, that's all from mine, Surya
Thank
Bhaiya.
you. Thank
Over
you,
to you.
Ravi. Thank you, Ravi. And now, if I can briefly ask my own couple of questions. First question, Dr. Santosh, is that at that early age, how did you uh, had that wisdom of choosing this unconventional path of mathematics and operation research? How did you take that leap of faith there without knowing much about that area?
No, as I mentioned, that when we joined the Defense Department, we were 47 people appointed in one appointment letter.
Yeah.
And they had no defined place for us. So, with mathematics background, we were three: one is statistics, two mathematics, and we were put in one group with this Colonel Subbarao. He had done some lectures, so he gave one lecture on linear programming, on graphical approach. And then he said, you take it over from here. So we used to get two journals, as I said, from USA, Operation Search, and quarterly of OR, quarterly from UK. And these were the two journals, very thin. They used to come in 2 months, 3 months. And we used to we used to give fortnightly seminar. So our turn used to come in 1.5 months because we were three people. So everybody fortnightly seminar, it was open to, and our seminars were not uh, what we have done. Our seminars were what we have been reading and including our difficulties. That I understood this part, but I don't understand the author is writing this to this. And I've been struggling with that. So we used to do that part to help each other take their problem and do. So defense introduced me to this field, and therefore ultimately I started working in that area and ended up with a PhD in that area.
Yep. Thank you so much. I'll request Subhash Sharma ji to ask his question, and then Neeraj
Thank you
ji.
very much. It's a very good presentation. We all enjoyed, I hope, I'm just wondering, that you said directional, non-directional issues, this is basically a systems approach, So how about, do you use graph theory, graph theoretical approach as well in
Yes,
this?
we do. We do. That
Hmm.
is what uh, uh, network and graph, one and the same thing.
Hmm.
Yeah, graph theory. Yeah.
Yeah, where relationships are, unidirectional or bidirectional, and instead of, taking when we prepare a matrix, rather than finding a determinant, we find a function called permanent, and that gives, the whole information. Uh, I've used it, for my engineering solutions, in the past. So I wonder, do you deal with these permanent functions type of things as well, in
Well, we deal with the metrics. Yeah, and that in the book which I was showing you. Um, um, in that we we call it reconstruction because we have got some mathematical logic in terms of why and how we change. And when we change uh, that change part, we call it reconstruction. So, um, for example, I was telling that if I subtract and add, so I have reconstructed the link distances or that relationship weights.
Mhm.
Not only that, we took it further. Uh, we took it to a larger graph, remove one by one reduce the size of the graph without losing the intention of that graph.
Information.
Yeah. So again, the idea is many of one rather than one of many.
Okay. Thanks.
Thank you so much, Subhash ji, and request Neeraj Nanda ji if you have any question.
Yeah, Santosh ji, I was just a few days back seeing a documentary on infinity in Netflix, and I had some idea about infinity, but I'm further confused after seeing it. So I just, as you mentioned about zero, so what is the relation between zero and infinity? So where
Well,
does zero stand in infinity?
well, to me, when anything is divided by zero, it's infinity. But I tell you, suppose we have a 1 cent in our pocket,
Mhm.
and everybody we meet, we give him the cent and take it back. To
Yeah.
how many people we can give? Infinite. It is, in other words, we are dividing one by zero because by giving and taking it back, we are not giving him anything.
Okay.
So our 1 cent is still intact. So when we meet the next person, we give him, take it back. So how many people we can give? As many as we meet, we keep giving. It will never end.
So which means it's never ending, basically.
Infinity is never ending. Yeah.
So you think zero also doesn't never ends, you know?
No, no. Zero, when you divide something by zero,
Yes.
you are not giving anything, you are not taking away anything from that, then it becomes infinite, you see.
And one more question.
Another interesting part about is that infinite and finite, they live together, you see. Body is one. So when we call a person, we count him as one person. But number of cells, number of hair on his body, number of this, number of that is infinite.
And one last question, which is just a very recent question in my mind, because I've been using artificial intelligence a lot in my media work, and maybe others are also doing it.
Yeah.
I find it a big achievement of humankind, like it or not. So where does zero, where is zero in it? You know, I mean, how do we relate it? You know, I mean, is it controlled by algorithm? What is it actually?
Well, I'm not clear about the question. Zero, you mean zero? In my way of looking at it, zero means you don't do anything, you don't give away anything, you don't spend any time. Zero means you spend zero. You
Oh yeah, okay.
see. So when that is why I was talking about that example. 1 cent. How many you can distribute? Infinite number, because you're giving to everybody and taking it back.
Yep. Okay. Thank you very much. Thank you.
Found a interesting definition of zero some time ago, that zero is a bag of all positive and all negative numbers put together. So net sum is zero, but when you that's the idea. That's where the infinity and zero comes together.
Yeah.
So, Santosh, I've got one more question that more, as you said towards the end of your presentation, that and the conclusion I was drawing when I was listening to you is that more we read, less we know.
Yes.
Absolutely.
Yeah.
And when you said that research is it's like an airport, lots of problem to solve and all, and more we read and less we know. And I was listening to one of the ISRO scientists as well recently in one of others webinar I did a month or two ago, that he said he has achieved a lot in life. He has done that the sun mission from India, He said he's done so many things, and now his life feels like he's done a lot more than. But where's the end? How does a researcher and scientist like you look at life in terms of never-ending problem solving?
It never ends because, as I was showing, the circle of unknown is bigger. So it gets bigger and bigger.
Hmm.
But how do you cope with that anxiety of it, that it's becoming bigger and bigger?
No, best anxiety, best thing is not to worry about it, what we don't know. But people who don't know, they are quite humble about it because knowing is very limited. Unknown is bigger.
Absolutely.
Yeah,
Okay. Yeah.
very thought-provoking ideas. Thank you. And
And
any
I I I mentioned that I visited Bellman's department. Uh, he himself, who has done so much in such a short period of life, uh, he was a very humble person. You see that because of his humble nature, he was sending me material from USA when I was in India. You see, I got a lot of material when other people were not able to. There were no books, nothing, but I was getting research papers, and I was a clean person, clean slate. You see. So whatever I was getting, I was reading that because there was nothing else. There was nothing in the library. You see, so I found him to be very, very approachable, very nice person. But the people working around him were not that easy. They had bigger chip on their shoulder than the boss himself.
so the key takeaway from your first or second slide itself, Dr. Santoshi, when you mentioned the second step is to find some pathway, right? If the
Yeah,
problem is very complex, the way to solve is to just move forward a step and try to figure out. So, and you have that n-1 problem left if you take one step forward, right?
yeah.
And that is what I was taking away as a lesson from your life when you took this unconventional path of operation research. When you take that unconventional path, you discover a lot of extraordinary people on your journey, and which is what you did. You met a lot of people in life, and they guided you. They became your pole star. They gave you notes. They gave you direction to your non-directed life, and they put some weight, and they changed the direction. They put virtual directions to your pathway and journey to research and all. So that is the takeaway I'm taking, that we should not fear taking unconventional path, and we should lean to meet a lot of intellectuals in the world and learn from them, basically take guidance and
Okay.
mentorship from them. So thank you so much for giving that inspirational thought during this webinar. So any other questions from the audience?
अरविंद जी कुछ कह रहे हैं क्या?
कैमरा
Arvind ji, you're mute. I'll unmute you.
अरविंद जी आप म्यूट पे हैं
नमस्कार सबको। कोई क्वेश्चन तो नहीं है, लेकिन मैं सिर्फ इतना कहना चाहूँ कि बहुत अच्छा लगा संतोष जी का ये सुनकर। तो really it was really inspiring, and in general Santosh ji always is a source of inspiration for many of us like me. So thank you very much, Dr. Santosh ji.
Thank you, dear. Thank you, dear.
Any other questions? Sarvesh Soni, not Dr. Sarvesh Soni. Sorry, Bekun ji, yes, over to you. Yeah.
Yeah. Thank you, Sury bhai. It's not a question. It is more of praise for Santoshi, what he has done. I really understood Santoshi or knew about him in mid-60s when he was at Defense Lab. So physically, I met him in 76 when I came to Melbourne. So since then, we got connection, and he has done wonderful work. And as operation researcher at RMIT, we had that Operations as a Society for Australia. So I have been president a few times of this Operations Research Society, and Santosh was one of the recipients of big accolade, you can say, medal for Operation Research, which Santosh has already mentioned that he had. So he has done wonderful work, and we have been together for a long, long time. So only I can say that he's doing wonderful work. He has his students have done wonderful work. He has been to Zimbabwe. He has been to RMIT. He mentioned somewhere 8 different universities all over the world. So he has traveled much, and he has done wonderful work. Thank you, Santoshji.
I may like to add this that my students from South Africa and Zimbabwe, they really gave me a purpose, and I continue to do work. And today I had a letter, email from Applied Maths. I published that paper in August 24. So the letter was congratulatory note that the paper has been downloaded
Good. Congratulations, Dr.
yeah, 1059 times.
It's a big
And
achievement.
it
Yeah.
has been cited once, and it has been downloaded 1059 times.
Very good, man.
So that,
Okay.
so
So
that
we-
work is possible only because I was continuously involved, and it gives me pleasure. And some of those problems are what we call mathematically NP-hard combinatorial problems. NP stands for non-polynomial hard problems, that is exponential algorithm.
And I thank you, Sury Bhai, for initiating this sort of seminar or series. Keep
Yeah.
doing it.
I think I would like to thank Dr. Santosh for that as well, because he gave this big push for this one, that we have got so many experienced talent in the community in Victoria, and we need a platform where we can talk about those experiences of life. I got so many good thought-provoking ideas from this webinar itself from Dr. Santoshji, that how to live a life. And it's not about mathematics, it's not about some nitty-gritty details of what he spoke about, but about the essence of his life has been passed on to us next generation through this small talk we can do. And that's a bare minimum we should do for the community, and everyone should actively participate. So thank you, Dr. Santoshji, for giving this idea. I'll request Dr. Sarvesh Soni Ji to say a few words.
Thank you, Suriji and Santoshi. I think I know, I think more than half of the people, those are present online. So hello to everyone, Santoshi, Nandaji, I think Arvind ji. So we had a long association with them from Sahitya Sandhya, and also it's an amazing platform that you have initiated, that we were lacking in the community, in the society, to have the intellectuals and the people who has been the master of their fields, and also can link, like the way Santosh ji did today, how he linked his mathematical journey in a very simpler words. And like, I'm a student of biology, so I could still able to understand what he was trying to explain. And it was really good to see all the senior people in the community to come together and guiding all the young, I still consider myself young people, to guide them forward. And Suriji, you as well, for the next path, and happy to contribute to this series whenever it is required, and share my ideas or anything that I have acquired in India, Australia, and happy to listen to all the new speakers as well. Thank you. And I'm really, first time, I think I was initially wondering that how come I'm logged in from two screens, because I saw another service Soni,
Yeah.
but that was not me. That was someone else. So
Mhm.
yeah. So no one else is using my account. So his real actual Sarvesh Soni, different from.
Sarvesh is my nephew from India. So welcome, Sarvesh Soni from India.
Thank you. And thanks, Santosh. I think I have met with you in Suresh's office a couple of times in RMIT.
Oh, okay.
Yeah.
Yeah.
So there
And
I met on.
with Suryaji, this Suresh would be very appropriate.
Yes, please inspire him to be available for
I
this
will
as
ask
a
him.
presentation. Thank you. And his speech on the Gandhi 2.0 was amazing. We'll request him to represent that one again as well.
Yeah. But he will be. He is very good in giving
Research.
popular talks and
Yes, thank
research.
you. Yeah, I'll connect with him as well. Thank you.
Okay, so Santoshji, we will wish that you keep doing this kind of work and inspire your younger generation people like us. And thank you very much for making this presentation. I wish that in future also anyone who could speak in a very generic form that makes his subject or his own experiences uh, approachable, that could be understood by a common man, so that will be good. You chose a very good topic, that makes, otherwise with the mathematics itself is, so uh, such a complex thing, that people may get away, that this is not for me. So thank you very much for presenting this topic, in such a nice manner. Thank you.
Thank you, Subhashji. I'll request Bill Gupta ji to say a few words as well, to unmute and say a few words. Yeah, thank you.
Gupta ji is on mute.
Yeah, thank you, Subhashji. Yeah, he's trying, I think. Yep, we can hear now. Oh, you.
Yep,
Yeah.
here it is. Santosh ji, you started OR roughly right from the beginning in 62. I joined first batch in industrial engineering in IT Delhi in 75. And we studied OR 1, OR 2, OR 3 in 3 semesters. At that time, computerization just started. Now, after that, now, so many years have lapsed, how you are still coping up the research in OR and publishing papers with the time of highly technical computerization? This was my question.
Well, I have disadvantage about it, see, because most of the journals want computational result programs, and I'm not able to provide that. I still put a numerical illustration, and I requested one or two computer scientists to join me, because if they wanted to, I've got enough work for them to complete a PhD degree in following the algorithms, and once you start doing something more will come up. But they all disappear. They all disappear in the middle, and we can only ask, and nothing has come up. Particularly, I was very keen for one paper, which is somewhat. I have not been able to find out this what are these 7 millennium problems, but I've heard. I was looking on the internet. I have not spotted myself that traveling salesman problem also is categorized as NP hard. But is it one of those 7 millennium problems? Because that has been done by me now in linear time. There's nothing. But that is where I was very keen, somebody to write a program of what I have done with my help. and then we do real computation on larger problems and put forward some more papers. But that is not within my capacity. By myself, I can't do it.
Thank you.
But he disappeared. But when I was talking to him, I got something out of him. And I've written a paper I'm submitting soon. And that was through him. He was looking into internet, and I have changed that whatever he was showing me on internet, and I think I have further streamlined that. Yeah.
Great work. Thank
Any
you.
questions from you, Sarvesh Soni from India, my nephew? Sarvesh, do you have any question? As a young student of mathematics.
Yes, I had one question.
Yeah.
Can you hear me?
Yes.
Yes, I had one question that how did you reach out to people like Professor Richard Bell when you were in India? Were you doing a
That was the
master's?
first paper I wrote on his work. And I had no idea how to write a paper. I had no idea how to publish a paper. And I had no idea. So I read something and sent it back to him. And that is how he picked me up. My address was that opposite the such and such hospital. That is our in India addresses are uske piche iske aage. that was my postal address. So I could not get it, but that is what he told me, that I'll get you in USA and I will be asking you to work on medical problems. So, because my address contained opposite such and such hospital. I had nothing to do with the hospital. So that is my contact was. But when I came to know more about him, he is the only professor I have come across with 3 titles. He was professor of mathematics, medicine, and engineering.
Wow.
I have never come across a person with 3 titles. He was the only person who had 3 secretaries. In those days, he used to dictate. And when there was no electronic thing, that time he has 76 books or something like that. So he was giving dictation, and his secretaries were mathematically good, qualified girls who were able to put his manuscript in the right order, then he will do one correction and send it, you see. So it was amazing to see that person, and I was very, very pleased to see him in face to face and spend some time with him. Yeah.
Yep. Thank you, Dr. Santoshi. And Sarvesh is first year student at IISc Bangalore in mathematics. That's where he's keen to ask this question.
I'm in second year ISI.
Second year. Yep.
And Jean Woolsey was very smart person. He has not done research, but he has done lot of applied work. And he gave me some good ideas. 3, 4 fields are open. In my opinion, they are unexplored fields. Whatever done, I have done something, and nothing much has been done in that.
Yep. Thank you. Ashish is operations technology person. Ashish, bhai, you want to ask any question?
Yeah, funny enough. Well, good evening, everyone.
Your video is not on.
We can't see.
Yeah, no,
Don't be
that's
shy.
fine. No, that's fine. But what I would like to say, thank you very much, Santoshji. And you will not believe it. My son, he's 11 years old and they are learning irrational numbers. And in school, they are learning pi and golden ratio and
Okay.
Euler's constant. So to make it interesting, literally, I asked him this question. He said, "Why?" I asked him, "Do you know why you are learning? Has your teacher told you?" And then it led one thing to another. So I may throw this question back to you, and I was trying to explain as a responsible parent to him that what is the purpose of mathematics in life? What does it do for you? So interestingly, you uh, explain this thing to us in a very nice way, philosophical way. I particularly, as others have said, the many takeaways from today's presentation, the circle of known, circle of unknowns. And as Suryaji also said, that you have to take the first step. And then every time you take that next step, it becomes an N minus one journey, N minus one step. So as they say, the you have to take the first step, then the journey begins. So I'm glad I listened to this lecture today, and I'm pretty sure that I can go back and say to him what is the purpose of mathematics in life and why is learning those constants.
That's good.
So thank you for that.
Thank you, Ashish bhai. And I'm very conscious of time. And if there's no final closing question from anybody, we would like to conclude the program by
And
saying
today this will be this has been
recorded.
recorded.
Recorded and will be shared with the community, and there'll be a regular series like this every Wednesday night 9 to 10 p.m. So please spread the word. Please be a regular attendee of this program. We'll learn life lessons from a lot of diverse speakers on this platform. I've already lined up 2 or 3. There might be a couple on this call as well in the upcoming. The flyers will be shared soon after this session, and so be a regular attendee of this program every Wednesday night, 9 to 10 p.m. And if you know who could be a good speaker on this forum and platform, please recommend, and we'll bring them on and learn from them. So the whole idea is we bring all the intellectuals, diverse thought leaders in our community or wider community for all us to collectively grow and share our knowledge. Any closing comments from you, Dr. Santosh ji? And first, Dr. Sarvesh, Soni, want to ask something first, then your closing comment.
Just a like suggestion, because like my daughter wanted to attend this session, but she has to wake up quite early. She's in high school, so 9 to 10 time I think doesn't fit well with the kids, young kids.
It's
So
students, yeah.
yeah, students or high school. So like if we can make it 8:30 to 9:30, that also fine. Or some like I'm fine with 9 to 10 from my perspective.
No, good suggestion.
Yeah, you can think for that, and anything that can make that group also we can include. It would be good for the next generation as well.
So kind of you. Yeah, Mindy, you're mute. You're mute. You're mute. You're mute.
Mindy, you are not muted. You are muted.
You have to unmute yourself. Yeah,
That
you
would-
can say it now. Yeah.
I think the frequency is a bit too much. Every Wednesday night is a bit too much. I think fortnightly or maybe once a month would be more reasonable. We have got other commitments on Wednesday nights as well. And to spare Wednesday night for this program every night, every week is a bit too much.
Sure. I'll take that note as well. We'll try with some frequency and try to adjust as we go, basically. So, and we'll be recording these sessions anyways. So if anybody missed, they can watch the recording, but we'll adjust our frequency as we go.
Thank you.
Thank you for the suggestion. Yep. I think we'll go with closing statement from Dr. Santoshji, and then I'll conclude with vote of thanks. Santoshji, any closing comments? Yeah.
Well, I just want to say thank you for spending your time and listening to me. We've been talking about it and congratulations. You have started. I hope the series will go on. Yeah.
Yeah.
Thank
Thank you.
you.
Thank you so much, Dr. Santoshi, for your spending time for presenting this very life lesson to us and inspiring lots of students to take mathematics as a mainstream subject. And we have been talking about this presentation for more than 2 months now, and finally it has happened tonight.
Yeah.
And with your blessings, we'll do it every more regular, frequent, and we'll bring more diverse speakers into this forum. And thank you so much for your first opening presentation to this series. So with that, I'll thank all our audience as well for joining late in the evening. And I wish and request you to join every frequent webinars like this and ask your questions. We want to make this as interactive as possible and spread the word. This is not bound or limited to Melbourne or Victoria. We can bring audience and speakers from anywhere in the world, basically, and we'll adjust our time and frequency as we go. And that is all. So thank you once again and have a great evening and good night to all.
Thank
Namaste.
you.
Good night.
Good night. Thank you.